All right. Hi, everyone. Welcome to the second half of the Python workshop that CPP Hyperloop hosts. The first one was last week, and we went up to conditionals, and we didn't get to finish the entire PowerPoint, so I'm here back again doing the second half. So today we'll be going over the second half of conditionals, doing the challenge problems, and hopefully getting all the way up to classes, imports, and the end of this, which should give you a good understanding of Python to begin coding up your own projects. So we left off actually doing this example, which is the grade calculator. Now, this example is used in like every single coding class I've ever been in. So it's pretty standard. Basically, you have a grade calculator that if you punch in a grade, and it's between any one of these ranges, it returns a letter. Yeah. Good idea. Oh, come on. That's a little bit. Hopefully, you guys don't notice that. Okay, so we did the grade calculator last time, in which if you put in a number grade, it'll return back a letter. And this letter would be between A and F, and we went through all the logic that required you to do this, including these if statements right here. So just as a review, for in Python, in order to put something under an if statement, because there are no semicolons, you use this colon symbol right here. And then you use indentation to mark that the contents are inside of the if statements. So in Python, indentation is really, really, really important. Sometimes the compiler won't even let you run the code if your indentation is incorrect. We have also else if statements in Python in which they just mark it as elif for shorter. And also we have else. So in case any one of these conditionals is false, it jumps down to the very end. So in this code, I'll just walk through it a little bit just to recap what we've done before. We have a variable grade in which the user will input it into the system, and then it'll jump to this logic block here. So if grade is greater than 90, it's going to go ahead and give the student an A, or it's going to assign this answer variable to an A string. If the grade is not greater than 90, if it's just like less than 90, then it's going to skip this first half, go to the second block, and then start comparing grade to 80. Now, if grade is greater than 80, then that must mean that the grade has to be between 80 and 90, because the first condition is false. Therefore, if the grade is above 80, we already know it's below 90, so it's going to assign the answer as B. If that is false, if grade is not greater than 80, let's say grade is 75, it'll jump down to this third conditional here, compare it to greater than 70, and then assign a student an answer or a grade of C. It'll continue until it reaches F. Now, this was pretty standard logic that we've covered in the previous workshop. A problem appeared when we began checking for the user input. Now, when you're designing any sort of user input system in Python, in C, or in any program language, you all automatically want to assume that the user is stupid. The user will try anything to break your code. And that's not the user's fault. That's your fault for not making the program great enough. So in this example, we went ahead and did a sort of janky user input restriction in which it would prevent the user from entering a number greater than 1,000. If the user enters in a string or something else that would break the program, it would ask them to write it again. The problem with this is that it went ahead and had this weird restriction of 10,000 and 1,000, and I really don't like it. So what I'm going to go ahead and introduce to you guys today is flags. In programming or hardware embedded systems, a flag is a really important tool. A flag is usually a Boolean variable, usually true or false, in which you can use that flag to do some other things, to check for things that are right or wrong, to check for if, let's say, grade is a letter or a number, to check for if your test passed the try-catch block and can continue to the rest of the code. So we're going to go ahead and write a flag instead of doing this numeric restriction in order to restrict the user's input. So I'm going to go ahead and delete this, and I'm going to go ahead and set grade to 0 as a default variable. Okay, so our logic beforehand was we want the user to be able to enter in something again and again, just so that if they fat finger and mistype some input so that it has a letter, they can enter it again. So let's say I type in J instead of a 9, then they can enter again. It won't go through the rest of the system and break the program. And we've had it here, right? We've had some sort of system in which it checks the student's grade and says, if the student's grade cannot be cast as an int, it'll throw an error and jump to this except block where it'll print E. Now that's great and all, except for the fact that if it continues onto the rest of the program, it's not very optimal because now you're going to try to process a string through this comparison, in which Python will then throw an error. Python hates you for it. So what we're going to do is we're going to do a flag that says valid input, and we're going to set this to false. So again, a flag is a Boolean variable that is always false or true, always 0 or 1. In this case, my valid input is going to tell me whether the user has put in something correct or not. So in this case, I'm going to say while not valid input. Now we went over the not keyword last time, which is why I'm going to use it here. But this basically says as long as valid input is false, I'm going to keep running through this script inside my while loop. And we haven't covered loops yet, but this is basically the format of a while loop. You put while here, and then your conditional or whatever you want to pass into the while loop after it. Remember, in Python, you don't need semicolons, you don't need parentheses. It's very free, unless it comes to like indentation, in which then it'll restrict the hell out of you. So in this case, we're saying, as long as our input is not valid, it's going to keep asking the user for something, for a grade, right? Now, we want to figure out our break statement next. How do we get out of this while loop? Now, we could use a break statement when it detects that the user has entered it in an integer, or we can go ahead and just put this one simple line right below grade. So if the user puts in something into the grade, that doesn't trigger an error, because as soon as it triggers an error inside that grade line, line 26, it's going to jump to accept. If I put anything after it, it's not going to hit it. So that means if I put something valid into grade equals int, and then I go ahead and set the flag to true, it goes true like this, then that means as soon as I put a valid input that doesn't error out with the int cast, it goes to valid input true, and then the second time it loops back around, that's going to be false. Line 24 is going to be false, right? Because while not valid input, while not true, is false. I went over the not statement last time, so that was a really bit of a headache to deal with, but that's where comments come into play. So if not valid input, or so this basically say if valid input is false, then loop, otherwise skip. So now if we have entered in a valid input, which means that our grade is an integer that the program siphons from the terminal, then it's going to go ahead and run the rest of the code. Otherwise, it's not going to. So let's try it out. So in this case, again, when you're using the input function of Python and you hover over this thing here, it gives you, IntelliSense gives you a list of things that Python likes, including the function, what inputs it has, what parameters it has. This is basically the doc string of the function. So Python automatically gives you a doc string of all the information that the function does. And it says that if you notice here, the function output is a string. And so for the inputs, when you process them inside your code, they'll automatically be a string unless you tell them otherwise. In our case, we're telling them otherwise by saying it's an int, right? So what I'm saying is that if we put in something that's not an integer, like whatever that is, and press enter, it's going to yell at us for being an invalid literal, right? And it lets us put in the grade again. So we can go ahead and put another grade. And as long as it's not a number, it's going to keep yelling at us and letting us put in another grade. And like in the case of user input, that's really, really useful because users are stupid. You don't want them crashing your program, right? So if we put in a valid grade, let's say we put in 80, and press enter, now it gives us a B. Because this 80 got past our while loop because it was a valid input. The program was able to cast it as an int and pass it down to the rest of the code. Therefore, it passed this condition statement, got to grade greater than 80, it got to answer B, and then print it out to terminal. And that's the grade calculator example in Python, using user inputs and flags. Any questions?
So there's a specific keyword for not. Can't you just use an exclamation here?
Yes, yes, you can. So that's a great question. So I'm going to show you the slide that we went over last time. So this is the slide that I presented for the not keyword. This is specific to Python. I mean, if you code in C++ and anything else like that, that's not a thing, right? In Python's case, because Pythoners, people who like to code in Python, love words instead of like actual symbols. Like if you see the if statements, they have and for the conditionals, and or, like the actual words and or. Let me go back. You see the and or? They don't like using the ampersand symbols or the vertical thingies, right? They use the and or statements. So they came up with not as a sort of way of doing the exclamation mark equals. And it works. It's really confusing, but it's great for troubleshooting, catching edge cases, and finding abnormalities in a data set. So to reiterate from the last workshop that I did, so one of the projects I work in is drones. I automate drones, make them fly for a long period of time. They run an automated script that grabs the camera data. And so camera data is really important because it tells us whether the drone is active or not, and whether we could get data from it or not. And so camera data is stored in this really big array of numbers. And if we check the array of numbers and there's nothing in it, so if I do if not camera frame and that returns true, then Houston, we have a problem. Our drone's somewhere in the Atlantic Ocean. We can't recover it, right? So in Python, we use not just as a sort of being simple, although we understand that it's not really the case for other programming languages. Does this make sense? But you can use exclamation mark equal. It'll give you the same thing. But in this case, because Python has this specific structure, it's a shortcut basically. So you just say not D equals true, and D being nothing in it. You don't have to say D has nothing in it because that wouldn't theoretically make sense. And this is the only exception.
Yep. So you said that data is from your visual or image data from your drone stored in an array.
Yes.
Well, is it numbers? Like how is that?
So we'll get to that one in the Python applications in more detail. In general, it contains an array of what color each pixel is on that frame. So usually camera data in OpenCV, or if you grab it from a webcam, is like a 640 by 480 frame of pixels. So every single pixel is stored in that array, and the RGB data is also stored in that array. So it's basically a block of data you can pass around and that machines can understand. Like we don't understand that block of data, but we can put it through a machine that really likes that block of data and can process it and do things like put filters on it, put masks on it, and analyze it for contours and objects, right? So it's the basics of machine learning and computer vision and detecting things that come from a data set. So we'll cover OpenCV and computer vision in more detail during the Python applications workshop, which is next month. Okay. I want to go over this challenge. Now, these challenges, there will be some challenges during today's workshop as well. These challenges are for encouraging you guys to think of more examples and think of more applications to these, the concepts we're talking about. So if you're watching this later on a recording, I encourage you to pause the video right now and go ahead and try to solve this problem. I'll go ahead and solve this problem right now just because I'm here. But there's a really good chance for you to practice your coding. Now, all of these challenges will have something to do with Hyperloop because this is the Hyperloop workshop, so they're all Hyperloop themed. They also have some sort of real-life application to them. So people who have worked in the Hyperloop pod will understand that some of this stuff is true. Probably not this one, but the later ones might be true. So this one is write a Python script to describe the following scenario. So the CPP Hyperloop pod reaches a futuristic junction and has 4 things to do. It can turn left, turn right, go straight, or stop moving. It's kind of like going into a 4-way street and turning based on whatever color the traffic light symbol is. The pod has an onboard camera that is able to detect a color on the sign and proceed according to the following constraints. So if the color on the sign is orange or purple, turn left. If the color on the sign is yellow or brown, turn right. If the color on the sign is green or blue, turn straight or go straight. If the color on the sign is any other color not mentioned, stop moving. Write a series of conditional statements that tells the car what to do given the color of the sign, which is blocked by my camera, which is user defined. So what I'm asking you to do is sort of like application / pseudocode combined, because you're not actually going to import a camera frame, you're just going to use the user input. So whatever the user puts into the program, what color it puts in, the car is going to behave accordingly. So in this case, we're going to go ahead and try to code this up here. I'm going to open Visual Studio Code. I'm going to keep working in the same repository. And then I'm going to go ahead and create another file just called podcolors.py. Okay. I'm going to go ahead and copy this statement into my compiler, and then using a multi-line comment so I can reference it later. Multi-line comments in Python use the triple quotation mark or triple apostrophe to do so. You can either use one of them. It gives us the same thing. All right. So based on this example, actually, I'm going to go ahead and introduce something new to you guys. So far, we have been coding in Python directly into the terminal. And what I mean by directly is that we don't have any sort of main function to encapsulate the script. It's kind of all over the place. You know, in Java, you have your system main. In C++, you also have a main function. Usually there's some kind of main function to have the code really neatly wrapped in a bundle. But Python doesn't have that, unless you do this. So I'm going to introduce what's called if name equals main. I'm pretty sure I did that wrong because it's not going to like me. Yeah, so main is in quotation marks, name is not. I think that's it. Let me check my slides. So this was a topic I was introducing at the very end. And I'll go ahead and do this now. So far we've been coding in Python through the terminal. We've been coding in Python through Visual Studio Code, but we haven't put it in any sort of main function. This is a specific thing, according to Python, that protects your code from being imported into the wrong areas. So if you write multiple Python scripts, and if you ever encounter this in the future, you might have to use functions from other files. And sometimes if you run the wrong file and you don't have this, it runs the wrong script. It's kind of weird to explain. But if you include if name equals main, and then you add an additional main function, then every time the Python script is run from the terminal, it's going to try to find this, right? Because this is on the very left indentation level, so this is definitely going to run. And if main equals main, which means if you're running this script from the terminal, then it's going to run a function called main. This is a user-defined function that you can use to write all your coding. And this is the best part about it. So this will be a separate function you write. And here's an example I stole from Tutorials Point that goes ahead and explains this in a little more detail. If you have a print statement on the very left indentation level, it'll always execute it. And then you have the name equals main. So if this is true, then it'll execute it when invoked directly. So basically, if you type Python 3, the script name inside the terminal window, and you run the script, this is what's going to say. Otherwise, if you import this script from another location, it's going to print executed when imported. So usually for like really large projects, you want to store used functions a lot in other scripts. So your code doesn't become like 1,214 lines long. I don't know what happened there. But if you call code from other functions, you have to be careful of where it's from. Otherwise, this will happen. So it's always safest to put if name equals main and then the main function underneath. And I'll do that right now. I always get confused, but name does not have quotations and main doesn't. Cool. So back to Visual Studio Code. We'll go ahead and do if name equals main and then get a main function inside. And then we'll do def main. Now, I haven't gone over functions yet, but to declare a function, use the def keyword. And then under main, if we do something like print hello world, you'll see that when we run the code, it'll act like normal. We have hello world in the terminal window. So we know this works. We know if we import this file into another location, it won't work. So this is good for file setup. Now what I'm going to do next is start writing the code. Now we have previously talked about user input as a form of error checking and making sure our code runs smoothly. And if we put this code onto a server that runs 24/7, it won't break down on us. So what we're going to do is, since this code requires a user input, we're going to go ahead and have a user enter in the color. So color, I'm going to set it as a string because color is usually a string. It's not going to be an integer because that wouldn't make sense. And then I'm going to set a flag called valid input. Now this is similar to the last one because we're going to use a flag to determine if the user has entered in a correct thing or not. Now I'm going to do this again. So while not valid input, so just to make sure that if the user does not enter in a correct color, it will ask them to do it again. Okay, at this point you might be thinking, wait a second. Last time we errored out because whatever the user input was not an integer. This time it doesn't have to be an integer. So what's going on here? The thing you can do in this case is because you realize that all of the items on the sign are colors. So you either have orange, purple, yellow, brown, green, or blue as valid colors. If you input in anything other than that, you should allow the user to either say it again, or you can go into the code and just stop the car, because it says if the color on the sign is any other color not mentioned, stop moving, right? But what if you type in something like armchair, right? If your code is not specific to detecting armchair as a color, then things can go wrong at that point too. So what you can do is you can go ahead and create a list of valid colors, and you're going to put in all the colors that are listed on the pod. So like, let's say orange, purple, yellow, brown, green, blue, and it says any other color not mentioned. So you can put more colors into this valid colors as well. So you can do like red, black, stuff like that, you know? Now what we're going to put in here is, in order for it to be a valid input, it must be in this list. A list is a specific data structure in Python that is mutable, which means you can add or subtract values from it. Addie? Oh yes, I misspelled orange. Thank you for noticing that. So a list is mutable. It's really cool in Python because you can append values to it, you can pop values from it and stuff like that. You know, so our valid input is if the user does not enter in a color, I'm going to change this to a color that is in the list, it will ask them to do it again. So I'm going to say, if while not valid input, I'm going to ask the user to enter in a color. So this input function, I'm going to say enter in a color, right? And I'm going to say if color, and I'm going to use a conditional here to check if the color entered was inside valid colors. So if color in valid colors, that's the cool thing about Python. You can use the in keyword to detect whether a color is inside a list or a string is inside a list. Can't do that with any other language. You got to write like a fun little function for that, you know? So if the color is in valid colors, we're going to set the valid input to true, right? Otherwise, if the color is in the color, or sorry, if the color is not in the list, we're going to go ahead and let the user know they messed up, and they can enter in a new color again. Sorry, this color is not in the list. Try again. So let's try this code out. Let's make sure our user detection or our user restriction script is working fine. So I'm going to go ahead and do a print statement here. So I'm going to say test worked, which means if the code is able to get out of that while loop and the color I put in is actually in the list, it's going to go down, skip through the while loop, and print test work. Let's test my theory. So I'm going to print. I'm going to go ahead and press play. I'm going to first put in a color that is not in the list. So like armchair, or just anything that's not on the list. Sorry, this color is not on the list. Try again. Good. That's expected behavior. Now let's try an actual color that's in the list. Something like orange. Test work. Which means my code was able to detect that the color orange, spelled correctly this time, is inside the list of valid colors. Set the valid input flag to true, and then the next time it loops around, it's going to say, while not true, is false. So it's going to skip past this, go to test work, and that's the code working. So now we just got to put in the rest of whatever we're doing. So in this case, the logic that tells the Hyperloop pod which direction to turn at that input. So we already have color. So at this point, color contains the direction that the pod needs to go. So all we got to do is I'm going to go ahead and say the direction as a new variable, because that's what I'm going to store the answer in. I'm going to say if the color, and again, I'm going to use a double equal sign in order to compare things inside of a conditional statement. So if the color is orange, so if the color is orange and the color, or because it can't be and, color is only going to be one thing. So if the color is orange or purple, so if the color is orange or purple, then I'm going to turn left. So direction, my direction is going to be left, right? Elif, right, because there's more options. So if the color is not orange or purple, then I'm going to go to the next statement. So it says if the color is yellow or brown, turn right. So now I'm going to go ahead and just copy paste. If the color is yellow or the color is brown, then I'm going to say direction equals right. Now the next one's pretty much the same. We're just using colors and saying the direction. So the next one says if the sign is green or blue, turn straight. So if the sign is green or the sign is blue, straight. And then otherwise, if it's none of the above, if the color of the sign is any other color not mentioned, stop moving. So else direction equals stop moving. Cool. Now I'm going to go ahead and print direction. I'm going to say use an F string. Actually, this is something new I haven't introduced yet. So an F string allows you to put variables inside your print statements in a really, really fancy way. So the direction that the Hyperloop pod will move in is, and then I'm going to use these curly brackets here, and I'm going to put the direction inside. So an F string allows you to put variables inside your print statements, and I have it right there. It's direction. So I'm going to go ahead and press play. I'm going to enter in a color. My color will be something like red, right? And then since red was not in the valid colors, it will stop moving. Now I'm going to put in something else, maybe something like orange. And it says the direction that the Hyperloop pod will move in is left, right? So it detected that if color equals orange, it'll go in the left direction. And if you guys have this exact same code, it should work for purple, yellow, brown, green, or blue, and any other color in the list. Yes?
How would you include how would you print a variable?
Good question. So if I didn't have the F string, alternatively, what you can use is something called concatenation. So you can go ahead and say the direction that the Hyperloop pod will move in is, and then you would put a space here, you would put a plus here, and you would say direction. So concatenation is the Python, or it's a coding way of smashing two strings together. So theoretically, if I run this, it'll work the exact same thing. So I'm going to put in a new color this time, so green. And it works. It moves straight.
So if that direction doesn't screen, you get an error?
Sometimes. So I know another coding language you do, but I'm not sure in Python if you will. And I'm not going to test it right now, but just to be safe, you can concatenate using a string. You know what? I'm going to test it right now. So I'm going to go ahead and set a variable to number equals 6. And I'm going to say test print number, and then I'm going to say plus number. Because I know in C this will not work. I'm going to say orange. Okay, it does not work. It yells at you. You can only concatenate string, not int to string. So what you got to do is you got to cast this to a string first, and then it should work. There we go. Test print number 6. Yeah, nice question. And that is the pod colors example for the Python workshop. All right, next we're going to talk about loops a little bit. Loops are fun. So we've already gone through the while loop bit, talking about flags and user input errors and making sure your code is smart enough to handle the user stupidity. Now we're going to talk more about loops and why we actually use them other than user inputs. So while loops? Loops are mainly used when the application requires an operation that you can repeat it multiple times. So it's kind of like if you have a process that you want to repeat and it's the same exact process every single time, then you will use a loop. So something like you wake up every morning, get out of bed, you brush your teeth, you have breakfast, you go to school. If you do that every single day, that's a loop, right? You may or may not know how many cycles to run through the operation. So for some loops, you might not know when to stop, right? Or if you do some repeated operations, there might not be a stopping point. I already answered the third question. The first thing we're going to talk about is while loops. So there's a lot of information on the screen, but while loops in general are used exclusively when you don't know when to stop. So there are 2 loops we're going to go over, while and for loops. In this case, while loops are kind of like if statements, while loops use conditionals. While loops use conditionals. So you'll see in the user input, we went ahead and did the while not valid input. The not valid input is a comparison that we make for it, what we'll call a conditional. It's a conditional that asks the program if the input is false or true. And if it's true, then not true is false, it'll skip the loop. Bad example, I know, very confusing. But the difference is while loops will execute their body as long as the conditional is true. So as long as the conditional is true, so let's say while true, right, then the while loop will run forever. Like while 1 equals 1, it'll run forever. An if statement is like if you finish dinner, eat dessert. While loop is as long as it's not raining, run along the track. Use this loop when you don't know when the operation should end. And I'll cover that next. So kind of like this flow chart here. We went over doing flow charts last time, and we talked about how it was a really great idea to make a flow chart whenever you code. Because if you're going to give this flow chart to someone else for them to code, they have to write the exact same code as you do. As I said last time, we can play a game called Telephone, in which the person in front of the line would code something, pass it behind them, and the person behind them would make a flow chart, then pass the flow chart behind them, and then the person behind them would code it, and it would just go on the sequence until you get to the very end. It would be like a disgusting mess of code. But we don't have time for that. But that's basically why you make flow charts and why you commentate on your code, to make sure that you get the best communication possible between you and your teammates. For loops. So the difference between while and for loops, and I never know the best way to introduce this. For loops, you use for loops when you know when something's going to end. So like, let's say you want to put 10 eggs in the mixing bowl when you make a cake. So because the eggs are the same every single time, and you know it's 10 eggs every single time, you're going to use a for loop in order to make this happen. So in the for loop, the body is executed n times, where n is the size of a list. Use this loop when you know how many times the loop should iterate. And there's 3 types of for loops, and I'll go over them right now. So the first one is for I in range 5. Now, for I in range is pretty much saying it'll run this thing 5 times, right? So run whatever's inside of this for loop 5 times. The second one says for I in range 0, 5. So these numbers in the center of the range function are known as parameters. If there's 1 parameter, it's going to assume that that's the number of times this loop should run. If there's 2 parameters, what do you think should happen? Yeah, so it'll run the for loop, and I is going to be the variable that contains whatever number gets run from 0 to 5. Now, is 5 inclusive or exclusive? Exclusive, correct. So it does not run 5. which means for this statement right here, how many times will this for loop run? 5, correct, yes. So it'll run this for loop 5 times. And then every single time it'll run, it'll store whatever variable is here inside of I. The last type of for loop is the for I and list. So if you have a list of items, like let's say our list of colors from the pod example, it'll go ahead and run the for loop for every single item in the list, and then store that item inside I. Let's take a look in the command prompt and how this works. So previously, we went ahead and used the command prompt as kind of like a Python compiler. And you can do this because when we set Python up, we included the what's it called? Blanking out right now. Path, correct, yes, path, thank you. So we included path, therefore we can go ahead and run Python 3 inside the terminal. Bam, we have Python. So let's go over for loops. Let's say I have a variable called results. I'm going to set result equals to 0. Now, what I'm going to do is I'm going to go ahead and make a while loop. And I'm going to say while true. And I'm going to say print results plus equals 1. Any guesses at what would happen? No, first it throws an invalid syntax error. Hold on. But you are correct, it's gonna run forever. Let me just go ahead and do a result plus equals 1. And this is the fastest way to break your computer, by the way. And print results. It's never gonna stop. Look how fast the number is increasing, by the way. That tells you the frequency at which the while loop is running, which is a lot. How many numbers is computing? The faster computer you have, the faster those numbers will go up. It all depends on clock speed and how much memory is allocated to your program. I'm gonna stop it here. You get the point. Okay. Let me go ahead and then resize this. All right, so let's do something like less stupid, and let's say, let's make something like Python 3. Let's restrict the while loop a bit. So there are a few ways to restrict it, and there is a way to convert while loops and for loops to each other. So let's make a result equals 0 again. And then I'm gonna say while results is less than 10. So this means as long as my result is under 10, the contents of this while loop will run infinitely. So if I do something like results, print results, and I press enter right now, what do you think will happen? What was that? It won't go up to 10 yet. That is correct. Was that what you said? Yeah. It'll run infinitely. There's no incrementation to result. This is not a for loop. Therefore, if I print result right now, what will it print forever? 0, that's correct. And I'm not gonna do that right now. So if we want something interesting to happen, we have to find someone to increment results. So I'm gonna say results plus equal 1. And then I'm gonna print results. Now, because we've incremented results by 1, what do you think will happen? Until it's 9, good. I like that specification. Is it gonna hit 10? And why is that? Correct. So what I just said is this code will run until it's 9 because it'll do result plus 1. Actually, yes, it'll run until 9. Let's test it. I was wrong. So why is it 10? Why is it not 9?
Oh, because it loops 9 times and then it's another 10.
Right. So what happened here was that the while loop looped 9 times and then went inside the while loop, added 1 to results, printed results out, and then it says 10. So it was 9, and then it became 10, and then it printed out, and then the while loop stopped. There is a case, and I can tell you right now that order matters in code, in which this will not happen. So here's the thing. I'm going to reset results back to 0. And then I'm going to write my new while loop a little bit differently. And notice this right here. I didn't see this either, but So if I print result first, and then did a result plus equals 1, this time what would happen? Now will equal to 9, and why is that?
It iterates, or it prints before it iterates, before it adds other ones.
Right. So it would print it and then add 1 to 10, and then when it went back with result as 10 and checked the while loop, it would skip it because it's false. This time it should be right. I sure hope so. There we go. 9. Now, here's the thing. If I scroll up here, you'll notice that for this one, it actually did run 10 times, but it didn't start from 0, right? Because it couldn't print it until it reaches 1. And in the bottom example, you can see it ran the exact same number of times. It ran 10 times, but this time it started from 0 instead of 1. So whenever you're doing something iterative, you just gotta remember that order matters. Watch out where you're adding a 1 to the while loop, whether it's at the beginning or end, because it really doesn't matter. Like for some scripts I've written, it really matters. And then execute your program. So it's whether for a while loop, it's whether you increment first or increment last, because you might need the result for something else. Let's go to for loops. Let's talk about for loops for a bit. So I'm gonna have my result equals 0 for again, my result equals 0. And I'm gonna say for x in range 5, and I'm gonna do print result. Oh, sorry, print x. Okay, who can tell me what this will print out? Would it be 0 5 times? Eddie?
There's no result in there.
Right, there's no result in there.
It's just gonna print, yeah.
What's it gonna print?
3, 5.
X. So X would be 1 through 5. Let's see if that's right. No.
0 through 4, excuse me.
Yes, because it starts from 0. So if you don't have a parameter in there, it's automatically going to assume you start from 0, although it's exclusive to 5. It does run 5 times though. So you see that? Yeah.
So like even if you didn't initialize X, like it would still print properly?
That's correct. Because you've already initialized X inside the for loop. Here's the thing about Python and why it's confusing compared to other programming languages. In other programming languages, when you instantiate a for loop, it'll be something like this. So you have for int I equals 0, I is less than 10, and then I++, and then you have your brackets, and then you would code everything inside of it, right? In a regular for loop, this is where you initialize it, right? This is where your conditional is, this is your increment. Remember, Python likes to be easy. Python doesn't like to be normal. So they try to simplify it by doing this. And in turn, it confused everyone. But it is easier once you write Python. So you can write really quickly without having to type that whole for loop thing out. So we had 4x in range 5. Now let me go ahead and change this up a little. I'm going to say results equals 0 for x in range. And now I'm going to say 1, 5. I'm going to print x. Who can tell me what's going to be printed out? Yep. 1, 2, 3, 4. And why is it 1, 2, 3, 4?
You're starting with 1 and going until 1 before 5? Before 5?
Right. And then 5 is exclusive, right?
Yeah.
Boom. 1 through 4. So for this top for loop, we didn't include the 0, and it just assumed we start from 0. In the bottom example, we stated that it must start from 1, not from 0. So that's how for loops work. That's how while loops work. You can do anything inside of the for or while loop, and it'll just loop through those X amount of ranges. You can run functions. You can do like threading. Yes. You can also, yeah. I'm not gonna say anything else. But what's that?
Oh, okay. I was wondering why you put the result there if you're not going to use it in the loop.
That was a trick question. That's tricky.
Oh.
Yeah.
You're just trying to screw us.
Yeah. Got you there. All right. So those are for loops and while loops in a nutshell. Let me just do one more. So I'm going to show you the list example. Okay, the cool thing about Python is that, the cool thing about Python, before it interrupted me, is that you can go ahead and shove anything you want inside a list and they'll approve of it. It's not a linked list. Pythons are not a linked list, but you can shove anything in there and it'll say, okay, I guess. So I'm going to show you the last one, which is for x in result. And I'm going to do print x. It's the last example, which is also very useful in case you want to rummage through a data structure. What do you think will print out?
Each element list.
Yeti?
I'm gonna say everything except false.
Sorry, what was that?
To say, never mind.
I heard something every time it's false?
Everything except false.
Everything is all false. Let's see. Okay, so it printed everything in the list. It was not exclusive to the last element, even though it was false. If you put none there, maybe it would do something differently. So it would print every single element in the list, which means if you're going through like some grades or like a grade book and you want to add 1 to every single element, you can do so. Well, you can't do here because like it's going to throw an error saying the string is not a number. But for example, let's say results was going to be a list of a lot of like grades, like 100, 90, 76, 85, 40. And let's say the teacher is like very nice and wants to give everyone extra credit, but doesn't want to go through each element of the grade book and do it herself. So you can do, for x in results, you can say x plus equals 1. Sorry. Oh, in this case, you wouldn't be able to do so because x is just a reference and not an actual number. I can't go back because Python doesn't let me. Okay, so what you need to do here, if you want to add 1 to every single item in that list, is you have to use a previous for loop. So what I would do is I would say for x in range, and I'm going to do the length of results as my range. So when you choose things through a list, if I say like result 0, I would choose the first one. This is the 0th element in a list. And then it goes 1, 2, 3, 4. Now, how many elements are in results? 5 elements, right? But there's only 4, I guess, places for them to be. 0, 1, 2, 3, 4. The length of a list is always the number of elements it contains. So if I use length results, this will give me 5. So for x in range 5, again, what does that do? What will x be?
0
Correct, 0 through 4. So if we use length results and we get 0 through 4 back, then we can do something cool called result x equals to x. Result equals to result x plus 1. So if I want to give everyone 1 extra credit point, then I would go ahead and use the iterator x to go through each element of the list using this searching function, and then add 1 to each of them. And this will not throw an error, because again, if we search 5, there's nothing here, right? There's no 5. It's gonna throw an error. But since the length results goes from 0 to 4 for x, it doesn't throw us an error. And so this one, I'm gonna do like print results. Dang it. Print result invalid syntax. Yeah. I have to like retype it all again. Okay, hold on. Result equals. This is the problem with doing everything in command line. 90, 76, 85. For x in range length of result x equals result x plus 1. And then print results. Okay, When you print a list, it'll return everything in this like neat little block here, and it'll add one, and like, because this list will print like 5 times. So you can see the progression of the list changing every time you run this again and again. So in this case, you'll have 91, because you're adding 1 to 90, and then 76 to 77, 85 to 86, and then 40 to 41. And then you can see all 5 of the lists changing like that. So that's how you iterate through a list and change values really, really quickly using Python. Automation. Okay. Here's a challenge, and I think I'm going to end this, I guess, episode. I guess I'll have to break this into 3 now. I'll end this episode off with a challenge, and this is write a Python script to describe the following scenario. The CDB Hyperloop team regularly runs endurance tests on the Hyperloop pod to make sure it is ready for competitions. Today, they decided to run the test 100 times with the following rules. Every 5 tests, the safety team must check on the pod's conditions. Print safety check during this test. Every 12 tests, the power team must replace the onboard batteries. Print battery replacement during this test. Every 10 tests, there's a 15% chance the communication system will blow out. If this happens, reset the system. Figure out a method to produce this 15% error. So at the end of the 100 tests, determine how many times the safety check, the battery replacement, and the comm system reset has happened. So this will be 3rd challenge for the Python workshop. All right, I think I'll have to go ahead and stop right here because I am running out of time. It's nearing the circuit analysis workshop, but I will continue this and talk about functions, classes. I think that's it. So probably 1 or 2 more episodes of this. But so far, if you guys are enjoying, thank you for listening. I hope you guys have a great rest of your day, and I'll see you next time for the recording.